Here's an example of a case of an elderly lady who presents with diarrhea. pH 744, CO2 12, O2 90, bicarb of 8, and anion gap of 22. I'm just going to stick it up here. First, internal validity. 24 times CO2 divided by bicarb equals 36, which is 4 points less acid than normal. That fits exactly with an alkalosis of 744. 4 points more pH than normal. Second step, what's the first primary? This is an alkalosis, and it's reverse. pH and CO2 are reversed, so it's respiratory alkalosis. Let's assume that the story tells you this problem has been going on for 3 days, so now it fits a chronic respiratory alkalosis. I want to see, is the change in bicarb appropriate for this much change in CO2? So CO2 has changed from 40 to 12. That's a 28 points difference. I'm going to multiply this by a particular factor. The factor is, if I draw the box, 1, 2, 3, 4, 5, respiratory alkalosis, that is acute, chronic, that is chronic, 0.5 equals 14. So I expect the bicarb to drop from 24 by 14 points down to a 10. Of course, everything in medicine is plus minus 2, so this bicarb of 8 is actually acceptable. So there is no the change in bicarb is as predicted. Now for the third primary, I already know there is anion gap metabolic acidosis. I need to find out, is there another problem with the patient? The anion gap is 10 points larger than normal, and the bicarb is 16 points lower than normal. So if I subtract the two, I'm going to end up with minus 6. I flip the minus onto its side, and because it's the third disorder I'm looking for, there is a non-anion gap metabolic acidosis on top of the anion gap metabolic acidosis. So in this case, it's not that we have 4 primaries. We actually don't have a second primary disorder. So you have the first primary disorder is a respiratory alkalosis, that's chronic, and then there's a second primary, that's an anion gap metabolic acidosis, and a third primary, that's non-gap acidosis. So what do you think happened to this poor lady? How did she end up with all of these disorders at the same time? So she presented with diarrhea that can explain bicarb loss, and with it maybe she developed renal failure that will explain the anion gap metabolic acidosis. And finally, there's something that's even stronger than the diarrhea and the renal failure, and it's a primary respiratory alkalosis, either pain driving the process, or a PE, or a toxin that she took. This is probably the most complex case that you'd ever encounter in clinical practice, but these cases are very similar to what you see in the ICU sometimes.